Hello, my name is Jack Berkowitz, and I'm the Senior Vice President of Product Development for ADP's Data Cloud. Really happy to be here today. I'm going to talk to you about how we're using ML solutions, how we're working with AWS extensively to provide insights for human capital management. What am I talking about? Data about people, data about you working and how your companies or how your organizations interpret information as you move forward. We're going to really just cover a few things. First of all, I'll go over who ADP is and what our data is, because that's the most important and most interesting part of everything. We'll talk about the data products that we build on using machine learning throughout the entire system. And then we'll talk specifically about the technical challenges that we've had and why the AWS solutions have really, met our need as we build product. And then we'll talk about our next steps and really the technical challenges we have moving forward, because as with everything in the space, everything's moving really rapidly and we're always looking to improve. So who is ADP? ADP is a massive company in terms of our reach in the human capital management or HR space. Now, a lot of you may know us as doing payroll, and we do a lot of that. So, but we also do things like taxes. We do things like HR management systems. We have a huge system for doing recruiting on behalf of companies. And we bring all that together. Company's 71, 72 years old at this moment. And a Fortune 500 mainstay in terms of scope. Here's some statistics for us. We have 810,000 clients worldwide. We do business in 140 countries. We represent over 45 languages. In terms of the types of things we do, like I talked about, we move a lot and we get ourselves concerned with a lot of things about people. And so we have 90 million employee records in our system. And if you think about even the US labor market, there's about 150 to 155 million people working in sort of regular jobs, W-2 type jobs. So we're representing a large portion of those. About 1 in 6 people currently get paid through ADP. And that represents, for example, $2.1 trillion moving through our systems. And so lots and lots of different types of information moving through our systems. And really what we wanted to do at ADP is to look at solutions where we could use that information for the benefits of our clients, or most importantly, for the benefits of our clients' employees, for you, right? Basically, whether that's recommendations when you're using our system or recommendations for improving your retirement savings or data to allow you to get your compensation benchmarks. These are the types of things that we wanted to do for our clients. Now, everything we do starts with data. And what do I mean by that? Well, we bring all that information together from all of our operational systems, all of the systems that are doing payroll or doing tax calculations or doing HR things like hiring or benefit selection. And we bring it together, and the very first thing we do is we anonymize that data. That data is highly sensitive. It's as sensitive as anything that people have, right? It's data about how much you make, or what your benefits are, or your marital status, or a range of things. So it's important that we anonymize it and we aggregate it. The next thing we do is we align it. Everybody says to me, well, what do you mean by align? Well, I'll give you an example. Every month, we pay about 30 million people, 30 million people in our systems. And of those, we have about 21 million job titles. But if we're going to do compensation benchmarking, we need to collapse it down not to 21 million job titles, but to maybe 6,000 or 8,000 job titles, and in our case, 9,000 job titles, so that you can look up a job. Well, it turns out to be a really, really, really hard natural language processing task to take 21 million job titles and crunch them down to 9,000 standard titles. And once we do all that, then we process that information, try to come up with, for example, what does a software developer make in Seattle versus software development make in Austin versus maybe one in New York or maybe one in Sioux City, Iowa. And that takes a massive amount of machine learning, a massive amount of compute capability to do it. We've been doing this for 5-6 years, and recently we've won a couple of nice awards. In 2020 and in the fall of 2020, we won an AI Breakthrough Award for the best AI solution for data science. And just in March, we won a Data Breakthrough Award for Data Analytics Innovation of the Year. Both of these were enabled because of the types of machine learning, the types of data that we move through our system. So who are we building these systems for? Well, really a lot of different users. Primarily, people think about the HR practitioner. This is the person inside your company who makes sure that you get paid, or that your benefits are there, or that your promotions are taken care of. We also build them for CXOs, whether it's the CHRO or the CFO, or in the case of somebody like myself, I'm not at the C level, but somebody who has an operational responsibility. I have hundreds of people that work in my organization around the world as an operational leader, or it could be a first line manager as well. But most importantly, and the person that we never want to forget, is we're building these for the employee. And so whether or not the information is at the employee's fingertips, or if it's the information that's affecting the employee's job, that's why we're building machine learning. And everything we do, we basically peg to what's the lift or what's the benefit that we're doing on behalf of that employee. And that implies things about privacy, that implies things about measuring gain as we go. All of that's done for the benefit of these people. And we solve a whole bunch of different problems. So one of the big areas right now is about maximizing employee retention. We're just in the middle of COVID. We're just coming out of it. But it turns out trying to keep people engaged and keep them energized inside of your company is a number one priority for a lot of firms. And at the same time, attracting new talent into the organization, managing labor costs, managing compliance and risk, driving agility, and I'll show you an example of that later on in the presentation. And really, a key aspect right now is all about diversity and inclusion. And we spend an awful lot of time taking that data, interpreting it, providing tools for companies to really increase their diversity and inclusion by measuring it. And once you can measure what's going on in your company, you can improve it. And that's a big deal for our clients. It's a big deal for ADP. So we take all that information, we take all the different pieces, and we build a number of products. And that's really what my team is. It's a product development organization. The first thing we do is we build a people analytics capability. And that is, a SaaS application that people can get metrics, can get augmented analytics. We call them executive and manager insights. We do organizational snapshots. What's the health of a company? And we have a really interesting technique, which is kind of unique in the business intelligence world, around storyboards, where we build narratives that explain complex HR concepts to everyday users. We do a ton of benchmarking, and that's what I was talking about in terms of compensation benchmarking. But we also have benchmarking for HR metrics. So I can tell you not only what a turnover rate is for your industry and your town, but I can also tell you what first-year turnover is. I can tell you things about what's the average time to fill for a posting, all sorts of different types of information. We have data explorers for pay equity. We do mashup capabilities, and we do organizational benchmarks. What's the structure of your company compared to all of your competitors? Are you putting more money into inside sales and your competitors still have salespeople out in the field? We can actually tell that from the data itself, and we make that available to clients. We also build AI and ML aids inside of the applications that ADP provides to its clients, or that ADP associates use in their day-to-day jobs. And so a great example of that is talent and recruiting, a candidate relevancy. Find me somebody like this person inside my organization so that I can fill an open rec, or I can go out and recruit for somebody. And then we also monetize certain pieces of that information because we make the same benchmarking data available for people doing things like demand planning. None of this would have been possible without machine learning as the heart of all of this. If we take a look at, sort of a architecture of what's come together or how it comes together, you can see all the systems on the left that we bring together. HR systems from ADP, but also other external systems where we bring information together. So for example, 70 external reference data sources, HR ontologies. I can't even believe we talk about ontologies. I started in the semantic web 20 years ago, and people would look at me funny when I said the word ontology. But today in the machine learning world, ontologies are part and parcel right there with your algorithms and with your graph databases. We bring that all together into a data lake, and we then calculate and do a number of things to then have downstream capabilities. The most important part about this entire architecture is you'll actually see the little people icons, because we take care of things inside of this flow about data quality. We take care of things about metric correctness, and we take care of things about the operations of the machine learning. We watch drift. We watch for bias using monitors that we've put in place. So that ML operations concept is how we run these systems day to day. Now, if we get into the benchmarking and insights features, these are the ones that a lot of people will call us up or talk to us, and they're very, very interested in it. What are these things? Well, when we look at compensation benchmarking, we have millions of usable data points that we can use to figure out what is the average compensation, what are the average benefits provided across these 9,000 jobs. In fact, we've built a neural network capability that allows us not only to look at the jobs where we have observed data, in other words, anonymized people in our data set, but we can actually now project with a high degree of precision to all 150 million regular workers in the US. We know, for example, what somebody should make if they happen to be a graphics designer in Southern California or a graphics designer working for a technology company in Chicago. We have organizational benchmarks where we can look at not just what people make or how they're staffed inside the organization, but we have a skills graph, and I'm going to show that to you in a minute. That skills graph 100% generated automatically from the data. And then, a classic use case, we can predict if somebody is dissatisfied and may be at danger of leaving your company. And we do it in a different way than many organizations because of all that data we have. So for example, although we've all been working from home, a lot of people are not working from home. A lot of people have to commute to work. And in fact, we're all about to start going back to work here shortly. We factor into our system not just the normal HR type things, but things about commuting patterns, things about peer compensation, either peers inside the organization or people in the neighborhood where people live. How are they doing? In other words, the whole context of the individual are factored into our turnover probability models. And again, as we go deeper into our benchmarking capabilities, you can see more and more machine learning components that we bring together to provide capabilities either into our applications, into other downstream reasoners, either built by my team at ADP or one of the thousands of people that are building product here, or into ERP systems. The interesting thing about it is all of these systems are alive. What do I mean by that? They're constantly taking data and feedback in this loop right here back into the system. So for example, we list here job match assertions. We have a machine learning thing that allows you to say, hey, my job is systems engineer 4. That means X in our hierarchy. But if you want to correct that, or if you say, no, I actually am a manager, not an entry engineer, that match assertion automatically feeds into the system, and the system automatically updates. This is really, really important as we build and scale our machine learning capabilities. So again, things about feature libraries and reuse, domain metrics, reference data, taxonomies, information about companies, all of this automatically being classified, managed, and processed, either monthly, some of it's quarterly, some of it's daily, some of it's streaming, all of it being brought together in a massive system for our clients. So an interesting thing about that is, and we've been working on this about a couple of years, and this was really uncorked when we moved into the cloud and into AWS, is we've been building a skills graph. What that skills graph allows us to do is to understand for a given job, what type of skills should that job have? Or even for a given worker, if they've worked at company A or worked at company B, what type of skills would they have gleaned either through their jobs or just being at that company? What type of skills should they have? In other words, we have declared skills, things that somebody might put in their talent profile or on their resume, but we also have inferred skills. I can tell you kind of, what a graphic artist, what type of tools should they have experience with? What type of techniques in terms of design would they have been exposed on as they develop their career? Now we do that by combining all the data and automatically processing it through natural language processing capabilities, and then we realize it into a graph. And we actually realize that graph in Neptune inside of AWS. And we use graph queries to bring together all of that capability. So it's sort of the fusion between machine learning and graph and ontologies all brought together to provide a capability. And we then expose that skills graph into different products, one being the organizational benchmarks, which I'll show in a second. We do it in terms of our intelligent sourcing. So, when you're applying for a role inside of one of our client companies, so if somebody's using our recruiting software, those skills are attached, or you can then correct those skills. So it'll preview it to you and you can say, yeah, that's me. I have these skills. Oh, you missed these other skills. You can add them. And then also into things like mobility. So we use a system inside of our company that allows us to find other roles as a talent marketplace. And that's where the skills graph really comes to life. We ingest data from all of these systems, bring it together. And one of the interesting things is it allows us to look at it in a very industry specific way. So for example, if you look here, we have generic skills for a project manager, but you can see that there's specific skills about the finance and insurance industry that might be different than a project manager in technical services. And yet again, different than a project manager in transportation and warehousing. So one aspect of all of this capabilities is allows us to get that fine differentiation as we go. So here's our organizational benchmarks capability. This is shipping product. And what you see is a taxonomy of the jobs that this company, Z's Hotel, happens to have. And right in line, you can see not only the skills for this banquet and head waiter, but you can see the compensation. You can also see the benchmark company that Z is comparing themselves to, right? So you can see, hey, they've got about the same representation of people in terms of the number of people. You can see the skills for those people, and you can see the compensation benchmarks. So if Z wants to see and compete against other entrants in the area, they can see it, and that can be done on headcount, labor costs, turnover rate, that was that HR metric I was talking about, span of control, all sorts of different things. Organizational benchmarks, very simple UI, but an incredible amount of data processing capabilities behind the scenes, all coming together, all put together using the AWS systems. So why do we do this? And what's the biggest problem that anybody like me or like you always gets? Yeah, that's great. You built a piece of machine learning, but can you help me with some other use cases as well? Can you help, for example, I got this one, that's great for the US, but can you extend it to Europe? Can you talk about maybe 10 or 20 other use cases? That idea, that notion of pace is really the thing that has been so important to us, to make sure that as we build this, it's componentized and everything is reused. We actually I traveled out to Seattle to sit down with Amazon almost 2 years ago to understand how Amazon does it. And then based on that, we kind of followed some of the best practices that they have and said, yeah, we can go ahead and build a componentized architecture for machine learning. Again, this is really domain capabilities, and then bring together new capabilities at a much faster pace. So when we were on-prem, and that's where we were 2 years ago, we had a ton of challenges. The biggest one was about data throughput and timeliness, but we also had time sharing of resources. We had a conventional cluster. And, literally I had people that had to stay up, until like 2 or 3 in the morning to have time to run their processing. We had deployment challenges. We had data centers to deal with. We didn't really know how to do drift monitoring or bias monitoring because we didn't really have the infrastructure to build the machine learning and deploy it and monitor it in real time. And again, the key point I was talking about in terms of pace, this notion of component and feature reuse or data reuse didn't exist. We were building a whole bunch of very one-off vertical stacks for each machine learning capability, and it would take us a long time to build it. And then we had no pace on the other side. So we decided, let's go ahead and move to the cloud. And so in the summer of 2019, we started that move. And we did it kind of in stair steps. The first thing we did is we moved the data, and we built our very first benchmarking pipelines. And we happened to do it a bit by hand. We tested SageMaker at that moment, but it wasn't quite ready for us yet. But the best part about the experience was we reached out to Amazon and we said, hey, we could actually use a few things. We could use a little bit of hardening on a couple of pieces of SageMaker. And by the winter of 2020, that's exactly what was happening. So, the fall of 2019, winter of 2020, we started to really get going. So we put our first production components in SageMaker, wrapped it with APIs, and we were moving with pay and earning code matching. And then we started to really get to going, right? We had to develop our own orchestration framework for our needs, but then we started to migrate a bunch of legacy models to SageMaker. Now, of course, what happens in the middle of all of this? COVID hits. And our organization had to move 58,000 people working from offices to working from home in 3 days. But guess what? Our ability to have started this movement to the cloud allowed us to actually accelerate during COVID, not decelerate. And that's an amazing thing. So by the summer of 2020, we had moved all of our ML processing to SageMaker in the cloud. We shut down 100% of our on-prem systems, just turned them off. We then started to accelerate the uptake of our models by other teams inside of ADP. And that started to get all sorts of reuse of the components. Our skills graph started to scale, and we went from sort of quarterly updates on our models, or quite frankly, yearly updates on our models, to monthly and weekly. So we're now monitoring things as they come in, and we can actually update our models if either the data shape changes or the model parameters change, and we get drift in the model, we can update them constantly. Where are we today? Well, we're moving to the central. We are now, moving to be the central data platform for ADP. We have all of these on-demand model updates with continuous monitoring. And our next big things are really about ML operations, really scaling that to a massive company, and data residency. As I talked about, we're in 140 countries around the world, and there's some strict data residency needs that we're just about to move into. So what's our situation today in AWS? Well, we've got about 20 ML services in live production. There are 7 teams working across ADP, reusing components that each other are building and scaling as we go. And that's really about this reuse of data, the reuse of feature libraries, and all of these machine learning components. We have on-demand access to GPUs that we never had before. And we can manage the cost, which is a huge deal to us. We have on-demand access to model building blocks, whether they're libraries like BERT or other capabilities that we might need. Our APIs scale incredibly well. And so, for some of our systems, particularly inline, we need to respond in tens of milliseconds, not seconds, but tens of milliseconds. And we're able to do that because we're able to scale our inference load. We're constantly monitoring now for drift and bias. So as models and as data is flowing in, we're watching it in real time. That's part of being a good ethical practitioner of machine learning, is to watch these things. We have 5 nines availability. I can't believe I can say that. I remember when 5 nines for any computing system was a fantasy, but that's exactly where we're at with our machine learning. We're able to do A, B, C, D, E, F, G model comparisons. And the biggest thing to us is that we changed our entire pace to deployment. It used to take us, when we were on-prem, 2 to 3 weeks to take a model and put it in production. We had to recode it. There were change orders needed, lots of different things. Now we have an automated CI/CD pipeline. We hit a button, and as long as there's a change order there and we're able to check it out of code, we can get a new model into production within a day, sometimes within a few hours. So what are our next challenges? It's really about ML operations. And I'm not talking about just building a model, even technically getting the model there. It's really the operations about what happens if the model misbehaves. Who takes the decision? Is it me as a product development person? Well, probably, yeah, but it's really a business leader inside our company. They're the people who need to understand the implications of machine learning. And so we're really about building machine learning operations for cost, but really for decision making. This is a key aspect to what we're going to be doing over the next year. Data mesh is an architecture that we're moving to. We're moving something like 3 petabytes of data around, 400 terabytes a day, streaming through this machine learning pipeline. And, just to get scale, we're really looking at data mesh, data residency. How do we have machine learning that can work on data in Germany differently than it works on data in the US, and it doesn't have to repatriate data or move data? This is a big challenge for us that we're looking at. Fine-grained permissions, who can access information, who can access the results. I think we're just starting with the explanations about models. It's one thing to explain a model to a data scientist or a citizen data scientist. It's another thing to explain the outcomes of a model to a recruiter or to an employee. And this turns out to be a really hard problem to solve. I don't think anybody solved it. And again, expanded use of machine learning across ADP businesses. And like I said at the end, did I mention ML ops? This to me, the past 6-8 years of machine learning have all been about building models. I've spent, a large portion of my time, almost all of my career looking at building models, ontologies, and all this other stuff. We know how to build these things now, but do we know how to operate them at massive scale for companies like ADP or companies like yours? And I think that that's the huge challenge for the industry to come over for the next 5 to 8 years. So this is a major deal that we're going to be working on. So thank you very much. My name is Jack Berkowitz. Really pleasure to be able to share our experience using Amazon SageMaker and all of the AWS capabilities. We have made great progress. There's my contact information if you want to reach out, either to talk about our journey or to talk about product ideas or needs that you have. And again, thanks for your time. It's been my pleasure.